Okay, number 15. A bacteria culture is started with 200 bacteria. After 4 hours, the population has grown to 779 bacteria. If the population grows exponentially, find the growth rate. Okay, so in this case, I know that P sub 0 is 200. Instead of dealing with years, I'm dealing with hours here. So I know that P sub 4 is 779. Just a second here. Okay, sorry about that. I had a phone call. All right. So I can use the form of, or the explicit formula to find the growth rate. And so what I'm going to do is I have P sub n is equal to P sub 0 times 1 plus R raised to the n. That's the general form. So I can replace these variables, with things I know. So P sub n, in this case, is P sub 4. So that's going to be 779. That's equal to 200 times 1 plus R. And n, we said, was 4. So all raised to the 4th power. Alright, so now the first thing I'm going to do is divide both sides by 200. And so on this side, I'm going to have 1 plus R to the 4th. And on this side, I'm going to have 779 divided by 200. That happens to be 3.895. 3.895. Then I'm going to take the 4th root of both sides to get rid of this 4th. So the 4th root and the 4th cancel each other out, so I'm left with 1 plus R. And in one of the information sheets for this unit, you'll see a little box that talks to you about how to take the 4th root, or take a higher root than the square root. So if you need to remember that or recall that, you can. You can do this on the calculator. So actually I'm getting, when I take the 4th root of 3.895, I get 1.40484. And then I'm going to subtract 1 from that. And when I do that, I get R is equal to 0.40484. Now, so that's that's R. It's in decimal form, so I need to move the decimal point over 2 places. And really, the rate is I'm going to say 40.5%. Okay, 16 says, a population of 50 deer are introduced into a wildlife sanctuary. It is estimated the sanctuary can sustain up to 200 deer. So as soon as I hear that up to 200 deer, I know that this is a logistic growth problem. And remember, for logistic growth, we just use the growth formula that we're given. So it's recursive. There's not an explicit formula for logistic growth. So P sub n is always equal to P sub n minus 1 plus the rate times 1 minus the rate over the carrying capacity K times P sub n minus 1. Not the rate. I'm sorry, this is not the rate. Let me erase that. Not the rate, but P sub n minus 1. So P sub n minus 1 should be in the formula 3 times. So P sub n is equal to P sub n minus 1 plus R times 1 minus P sub n minus 1 over K, and multiply all that by P sub n minus 1. All right, so for this, we're going to find how many deer are there after 1 year. So that's P sub 1. That's going to be equal to P sub n minus 1. So P sub n minus 1 is P sub 0, and remember that P sub 0 for us is 50. So the first year there were 50 deer. So this is going to be 50 plus 0.60 times 1 minus 50 over 200 times 50. And when you reduce that, I get 72.5. When you simplify that expression, you get 72.5. I divide 50 by 200, subtract it from 1, multiply by 50, multiply by 0.60, and add to 50. And I think you get 50 plus 22.5, or 72.5. So what about the deer population after 2 years? So that's P sub 2. So that's going to be P sub n minus 1, or P sub 1. So 72.5 plus 60%, or 0.60, times 1 minus 72.5 over 200 times 72.5. And when I multiply all that up, I get 100.23. All right, let's look at number 17. Number 17 says, Helena borrows $1,400 and must pay it back with 2% interest after 10 months. What is the total amount Helena will pay back? So this is basically just a simple interest problem. So we don't want to use the interest formula, though. However, we want to use the future value. So A with simple interest is equal to P times RT plus 1. So I'm going to fill this in. So A is going to equal 1,400 times 2%, 0.02, times 10 months. Now remember, T is always in years, so 10 months is 10/12 of a year. Plus 1. So 0.02 times 10/12 plus 1 times 1400. If I multiply all that on the calculator and add that, I'm going to get 1423.33. So that's how much she's going to pay back. Now, Melanie invests a total of $29,000 into 2 accounts. One paying 2% simple interest and the other paying 3% simple interest. So how much was invested in each account if the total interest earned after 1 year is $710? Alright, so I know that I have 2 accounts. So I'm going to call this account 1. And I'm going to have account 2. So in account 1, I don't know how much I'm going to put in either account. So let's say that I put X in account 1. In account 1, the interest rate is 2%, so that's 0.02. And I have the account open for 1 year. In account 2, I'm not sure how much to put, but I do know that if I have $29,000 total and I put X in account 1, in account 2 I'm going to have $29,000 minus X. That's going to be at 3% simple interest, and that's going to be for 1 year. So I also know that if I take the interest in account 1 and add that to the interest in account 2, I'm going to get the total interest, which I know to be $710. So I can create an equation by saying X times 0.02 or 0.02X plus 0.03 times 29,000 minus X. And I multiply both of these by 1, but that doesn't change them, but that's for the 1 year. Now I can solve this equation. So this equation is going to be 0.02X plus 0.03 times 29,000. That is 870. And then I have 0.03 times X is 0.03X. Alright, 0.02 minus 0.03 is going to be negative 0.01X plus 870 equals 710. And when I subtract 870 from both sides, I'm going to get negative 0.01X is equal to negative 160. And if I divide by negative 0.01 on both sides, X is going to equal 16,000. So 16,000 is what I put in the first account, and if I find 29 minus X, so 29,000 minus 1,600, or 16,000.